Hello amazing learner, welcome back to the Zoom Chemistry Hub. Today we will discuss what is colligative properties and what are its importance. So colligative properties are the properties of solutions that depend only on the numbers of solute particles, not on their types or nature. The word colligative comes from the Latin colligatus, meaning bound together, because these properties are linked with the number of solute particles in the solution. There are four types of colligative properties. First, relative lowering of vapor pressure. Second, elevations of boiling point. Third, depressions of freezing point. And fourth, osmotic pressure. Let's understand them one by one. First, relative lowering of vapor pressure. When we add a non-volatile solute like sugar or salt to a liquid like water, the vapor pressure of solution becomes lower than the pure solvent. Why this happened? Because the solute particles block the surface and pure solvent particles escape into the vapors. Formula for relative lowering of vapor pressure is P naught minus Ps divided by P naught is equal to X solute, where P naught is the vapor pressure of pure solvent, Ps is the vapor pressure of the solution, and X solute is the mole fraction of the solute. Next is the elevations of boiling point. This is the second property of colligative. Adding a solute to a solvent raises its boiling point. Why this happened? Because the vapor pressure decreases, so we need more heat to make it boil. The formula for elevations of boiling point is del Tb is equal to Kb into m, where del Tb is the increase in boiling point, Kb is the abelioscopic constant, and m is the molality of the solution. Examples: adding the salt in water when cooking pasta, it boils at a high temperature and cooking faster. Now in this formula, a constant Kb, this is called abelioscopic constant. What is its mean? Abelioscopic constant is the boiling point elevation constant of the solvent. It tells us how much the boiling point of the solvent increases when 1 mole of solute is dissolved in 1 kilogram of the solvent. That's why it appears in formula. And abelio means for ebullitions, which means boiling. So it is denoted by Kb, and it is equal to boiling related constant. So Kb is the boiling related constant. This is called abelioscopic constant, Kb. Is the colligative properties, that is the depression of freezing point. When we add a solute to a liquid, its freezing point decreases, so it freezes at a lower temperature. Formula for depression of freezing point is del Tf is equal to Kf into m, where del Tf is the decrease in freezing point. Kf is a constant. This constant is called cryoscopic constant, and m is the molality. Examples: in cold countries, salt is spread on the road to lower the freezing point of water and prevent ice formation. This process is called de-icing. And here a constant is mentioned, that is cryoscopic constant, that it is indicated by Kf. And what is cryoscopic constant? Cryoscopic constant is denoted by Kf, and it is defined as the freezing point depression of the solvent. It tells us how much the freezing point of a solvent decreases when 1 mole of solute is dissolved in 1 kilogram of the solvent. That's why it appears in the formula, that is del Tf is equal to Kf into m. Cryo means cold or freezing, so Kf is equal to freezing related constant. Next is the osmotic pressure, that is the last and fourth colligative properties. Osmotic pressure is the pressure needed to stop osmosis. What is osmotic pressure? It is the flow of solvent into the solution through a semi-permeable membrane. Formula for osmotic pressure, that is pi is equal to ICRT, where I is the Van Hoff factor, it is denoted by I. C is the concentrations, mole per liter. R is the gas constant, and T is the temperature in Kelvin. And here pi is called the osmotic pressure. Used in real life. This property is used to determine the molar mass of the large molecule like protein. Plants use osmosis to absorb water from the soil. Summary. Dear learner, these properties are called colligative because they don't care about the type of solute, whether it is a sugar or salt or urea. What matters is how many particles are present, not what they are. And if dissociation or association happens, like sodium chloride breaks up in dissociations, we use the Van Hoff factor to adjust all the formulas. If you think helpful, please like, subscribe and share this video with your friends and fellows. Thanks for watching.